Welcome to Mimi's Math Channel. Today I'm going to discuss graphing quadratic inequalities using Desmos. So as you can see, I have shown a chart where it's going to tell you what the lines mean once you go to Desmos. So for instance, if they're dashed lines, that's going to mean you either have a less than or greater than inequality. And on a number line, that will be indicated by an open circle. So I'm either going to have two options in my class. So either the interval that's in the middle between those two critical points will be shaded, or the first interval and the third interval will be shaded in. And then if you look on Desmos and you see solid lines for your graph, that indicates that not only are the points included on your number line, but that's going to be a less than and equal to or greater than and equal to inequality. So for the first example, and for all of the examples, I showed you how to actually solve for it as well. So you see the work here, but the purpose of this video is to show you how to use Desmos. So your first step is that you're going to type in this inequality in Desmos, just as you see it. It's going to be x squared minus 8x plus 12, which is less than or equal to 0. So if you want to use your keyboard, you would just press Shift and then the comma sign and then press equal, and it will give you this. Or you can go to where the keyboard is shown for Desmos, and then you can see your inequalities listed here. Once you do that, it shows you over on the graphing side the two critical points. So in our case, it's 2 and 6, and you do want to put them in order from smallest to largest. And then it shows you that it's a solid line. So that indicated that I had that equal to portion under my inequality. And it says that it's going to be shaded in the middle. So if you go back to the portion where I manually showed it to you, this is what it would look like. In my class, I want you to use interval notation. So between 2 and 6 in brackets, this is what it would look like. If you were using the inequality notation, then what you would write is 2 is less than or equal to x, which is also less than or equal to 6. And that's telling you that x can be any number that falls between 2 and 6. This is also, if you're showing your work, what you would do, you would just take some of the points from those intervals. I personally like to use 0 whenever possible. So 0 falls on this side, and then I take the number directly after my critical point. So 2, 3, and then 6, 7. If it were like 1.5, I would just take the next whole number, which is 2. And then I just test it. False, true, false. The part that's true is the part that you're shading in. All right, for example 2, here I am going to take this inequality and I'm going to go back to Desmos. And this time, once I type that in, I see that I still have critical points. I have -1, and then I have 0.333 repeating. If you look at the work, I have 1/3. So 1/3 as a decimal is that 0.333 and then -1. But if you wanted to test it, you can just type in 1 divided by 3 and you will see that it's going to give you that same value that was given over on your Desmos graph. This time you see that you have dashed lines. That indicates that you did not have a greater than or equal to. You just had a greater than. It also tells you that the intervals on the outside of the graph are what's going to be shaded in. If I go back here and I look at my graph, I have open circle, which indicates that I just have greater than without the equal to sign. And then the outside portions, once I test them, I see true, false, true. And so the parts that are true are the parts that are going to be shaded in. Interval notation, you would write it with parentheses because negative infinity and positive infinity are never included. And then once you have your open circles there, that tells you it's not included as well. If it were shaded in, those points are actually included. And then the last example has 2 parts to it. So for this first one, I noticed when I distribute this out, 2x minus 14 is going to equal 2x plus 19. 2x and 2x, once I subtract it, it's just going to zero itself out. But I'm still left with a statement that's true. So if that ever happens, that is going to be infinitely many solutions, which means you're shading in the entire line with the arrows included. And then the interval notation will be negative infinity to positive infinity with parentheses. No matter what x I put in for 2x, on this side, I'm going to be subtracting 14. On the other side, no matter if I put that same x in for 2x, I'm now adding 19. So no matter what number I put, this statement will always be true. All right, so let's go to Desmos to see what it looks like. And now you see everything is shaded in, and I don't have two critical points because I didn't solve for anything. The x's disappeared. So therefore, I could use any number in the place of x and it would work. Let's see if we change this to greater than or equal to, what would happen? And now you notice I don't have anything shaded, which indicates that that's no solution. So if I were to do the exact same thing that I said a few minutes ago and substitute in numbers, it doesn't matter what I put in. Let's just say, let's put in a 7, because then that means that this is going to be 0. So 0 times 2 is going to be 0. I see that, yes, it is still no solution because 0 is not going to be greater than or equal to 14 plus 19. So no matter what number I put in for x, it is still going to be no solutions when my inequality looks this way. So this is what your final answer would be. There's nothing to graph. Thank you for watching. Remember to like and subscribe. Have an awesome day.